The theory of constraints was first introduced by author E.M Goldratt in his 1984 book, The Goal. He then further refined and adapted the idea in his 1997 book, Critical Chain, which shows how the theory can be applied to project management. The theory states that every system has room for improvement and the current performance is bounded by the most limiting constraint. Following that to its conclusion, removing the most limiting constraint will have the effect of instantly improving the performance of the overall system, which will then be limited by a different constraint. A useful metaphor is to think of a system as a chain consisting of many individual links. Under extreme tension, the chain will fail at its weakest link. In other words, the performance of the overall system is bounded by its most limiting constraint. If we work to strengthen the weakest link, the performance of the overall system will be improved, and the new limiting factor will be the next weakest link. Any time spent improving the performance of anything but the weakest link is wasted. The theory of constraints provides a set of 5 focusing steps designed for identifying and eliminating constraints within a system. Step 1 is to identify the most limiting constraint, the one that bounds the performance of the overall system. Step 2 is to make quick improvements to the throughput of the constraint. This can be thought of as making the most of what you have. Are there any obvious measures that can be taken to prevent this part of the system being the most limiting constraint? Step 3 is to review the other connected parts of the system to ensure that they support the needs of the constraint. For instance, is one part of the system flooding the constraining part with requests? Could the calling code cache some results or be optimized in other ways to reduce the number of requests? If, after applying the previous steps, the constraint is still limiting the overall performance of the system, elevate the priority of the work required to fix the bottleneck and proceed with this work until it is no longer the most limiting constraint. The final step is to repeat the process. This step is a reminder that there will always be a part of the system which limits the overall performance. After all, if there was nothing preventing a system from achieving better performance, its throughput would be infinite, which is impossible in a real-life system. Whenever we set out to implement a new system, we should be sure to work with customers to define a precise set of service-level agreements. These SLAs will detail the overall performance of the expected system in terms of speed, availability, scalability, and a number of other factors. By rigidly applying the theory of constraints, and thereby acknowledging that the performance of a system can always be improved, we can see that there will always be opportunities to work to remove constraints. However, the theory should only be applied until the system performs comfortably within the agreed SLAs. Any time spent working on performance improvements beyond that is likely wasted, as the system will never be pushed to those limits. Therefore, it is important that we are able to monitor the performance of the system according to our SLAs in order to know not only when they have been breached, but also when they are consistently being achieved.